Number series looks intimidating, but it's really a guessing game with rules. The exam uses the same 5 or 6 patterns over and over, so once you can recognize them on sight, these become some of the fastest marks in the paper. The whole skill is knowing where to look first, and that's always the same place. Your very first move on any series is to write the differences between neighboring terms. 3 to 7 is 4, 7 to 11 is 4, 11 to 15 is 4. When that gap stays constant, you have an arithmetic series. You simply keep adding the same number. Most easy series are exactly this, and spotting it takes 1 second. If the numbers grow too quickly for addition to explain, check the ratio instead. 2 to 6 is times 3. 6 to 18 is times 3. A constant ratio means a geometric series. You multiply by the same factor each time. Rule of thumb: small steady jumps mean addition. Explosive jumps mean multiplication. Sometimes the gaps aren't constant. They're 3, 5, 7, 9. Don't panic. The differences have their own pattern. Here are the odd numbers. So the next gap is 11, and the next term is 27 plus 11. Whenever the first row of differences isn't constant, look at the differences of the differences. Memorize the look of squares: 1, 4, 9, 16, and cubes: 1, 8, 27, 64. The exam loves to disguise them by adding 1 to each, so 2, 5, 10, 17 is really squares plus 1. If the series feels almost square, test that. Some questions give you a series with one term deliberately wrong and ask you to spot it. Same method. Find the pattern from the terms that agree, then catch the one that doesn't fit. The trap is always a number that's close but not exact. 8 questions, easy to hard, including a wrong term one. Wonder why? Always start by writing the differences. 3, 7, 11, 15. Then what? The gaps are all 4, so it's arithmetic. Add 4 to 15 and you get 19. Nothing fancy, just confirm the gap is constant and continue it. In the exam, arithmetic series are the gift questions. If the first 2 gaps match, commit and move on rather than checking every term. 2, 6, 18, 54. Next, please triple every step: 6 over 2, 18 over 6, all 3. So it's geometric. 54 times 3 is 162. A quick tell for geometric series is that the numbers roughly double or triple in size each step. If addition cannot explain that jump, check the ratio once. 1, 4, 9, 16. Next, 1, 4, 9, 16 are the squares of 1, 2, 3, 4. The next square is 5 squared, 25 determinant. The moment a series matches the squares, you're done. Keep your squares up to 20 memorized. A large share of pattern traps are squares in disguise, sometimes with a small constant added to each term. 5, 11, 23, 47. Next, the gaps double: 6, 12, 24, which is a sign of times 2 plus 1. Check. 5 times 2 plus 1 is 11, and so on. 47 times 2 plus 1 is 95. The times 2 plus 1 family is common. Spot it when each gap is roughly double the previous gap, which plain addition can never produce. 2, 3, 5, 7, 11. Next, no arithmetic pattern fits, because these are the prime numbers: 2, 3, 5, 7, 11. The next prime is 13. When the gaps look irregular and the numbers are all prime, that's your clue. Primes follow no arithmetic rule, so if no difference and no ratio fits and the numbers are all prime, that is your answer. Know the primes to 50 cold. 1, 8, 27, 64. Next. 1, 8, 27, 64 are the cubes of 1, 2, 3, 4. The next is 5 cubed, 125. Cubes grow fast, so a steep series that isn't geometric is often cubes. Cubes grow even faster than squares, so a steep series that is not a clean geometric one is very often cubes. Test 1, 8, 27 first. In 4, 9, 16, 24, 36. Which term is
These
wrong?
should be
the squares. 4, 9, 16, 25, 36. But the fourth term is 24, not 25. So 24 is the wrong term. It's the one that breaks an otherwise perfect square series. For wrong term questions, fix the rule from the terms that agree, then hunt the odd one out. The trap is always a value that is close, but just off. 3, 6, 11, 18, 27. Next, the gaps are 3, 5, 7, 9. The odd numbers. So the next gap is 11, and 27 plus 11 is 38. When the differences aren't constant, their own pattern gives you the answer. When the first row of differences is not constant, take the differences again. That nested pattern, here the odd numbers, is a favorite at the harder end. 195, 90, 85. Next, the gaps are -5 each, so this is a descending arithmetic series. Subtract 5 from 85 to get 80. Descending series behave exactly like ascending ones, so just confirm the gap is constant and keep going. The common slip is to add out of habit, so always read the direction of the gaps first. 1, 3, 7, 15, 31. Each term is double the one before, plus 1, 1 to 3, 3 to 7, and so on. So 31 times 2 plus 1 is 63. The giveaway is that the gaps themselves keep doubling, which a plain arithmetic series can never do, pointing straight at the times 2 plus 1 rule. So the routine never changes. Write the gaps. Constant gap add constant ratio multiply. If the gaps change, find the pattern in the gaps and keep your squares and cubes memorized so you spot them instantly. Do that and number series becomes free marks. The 20 question practice set is next. Subscribe so it reaches you, and I'll see you there.